Good morning, grade 9. Today we're going to talk about how to simplify algebraic expressions. So at the right side, for example, you see a very long algebraic expression. To simplify it, I need to combine. Combine what? Combine the like terms. So in the left side, I want to check which one really it's a combine terms, or which one is like terms, so I can combine them. So I'm going to answer if the left side is like term with the one in the right side. If it's yes, I'm going to write yes. If it's no, I'm going to write no. So is 4x, I can combine it with 2x, or with another question, are they like terms, which means they are from the same family? Yes. Even if the coefficient is different, I don't care. This is a value. So if I have 4 apple and 2 apple, yes, they are like terms. 2x squared and 4x. Here, the answer is no. Why no? Because x to the power of 2 is different than x. It's not because of the coefficient, because of the exponent. 4xy and 2yx. Do you think they are like terms? Yes. Someone will say, but this is x, y, and here it's y, x. Actually, in multiplication, we don't care about the order. But x, it's only x to the exponent 1, or to the power of 1, and y to the power of 1, so they are not different. 3y squared x and 4yx squared. Here, we're going to say no. Why no? Because you see the exponent of the y here, it's square, but here it's 1. And here the x had power of 1, but here x to the power of 2. They are totally different. What about 4x and 4? For sure, the 4 here, there is a hidden x to the power of 0, because x to the power of 0 equal to 1, as you know. So x to the power of 0 is not like term with x exponent 1. Therefore, we say no. Or you can say that this is 4 as a constant, but for x, it has constant and value. AB and ABC, are they like terms? For sure, no. There is C here, there is no C here. AB squared and AB. Yes, AB are existing here, but one with B squared and one without B squared, with B only. So therefore, no, they are different. Negative 2y and 4y. Yes, they are like terms. Even if the coefficient is negative 2 and 4, who cares about the coefficient? But the y and the y exists in both, so they are like terms. 4dc squared, negative 3c squared d. You see here, the c squared exists in both, the d exists in both. That means, yes, they are like terms. We don't care about the order with the multiplication. Negative 4 and 5, yes, they are like terms, because both they have a hidden x exponent 0 or any variable exponent 0. So in this case, yes, they are like terms. Now let's work a little bit with this one. So if I have 2a, 5a squared minus 3a plus 7a squared minus a squared plus 4a. Some students, they have the habit to do it like that. They can combine the like terms by underlining the same or the like terms with this way. So they can say that 2a and negative 3a and positive 4a, they are like terms. So 2 and negative 3, it's negative 1. Negative 1 and 4, that means 3a. The next one, you can square it if you like, all the like terms for yourself, so you don't miss anything. So I have 5 and 7, it's 12. 12 minus 1, it's 11. That means 11a squared. And you see here, this very long algebraic expression, it became to this short algebraic expression. They have the same value, and that's why we call it simplification. Let's continue with another example. Again, how can I simplify something like that? For sure, you can see here that I have an algebraic expression that I need to use a distributive property before I simplify it. So I'm going to say this is equal to 9a plus 10 times 6a, that means 60a, and positive 10 times negative 1 equal negative 10. Now I can combine the like terms if there is. So I see 9a and 60a, so that means 69a, negative 10. And this is going to be my solution. The one here in the right side, I see again the distributive property. I have to run it twice. So negative 10 times 1 equal negative 10. Negative 10 times negative 9x, that means positive 90x. Positive 6 and positive x, that means positive 6x. And positive 6 and negative 10, that means negative 60. Now I can combine the like terms if I have. So here the constant with the constant. So that means negative 10, negative 60, that means negative 70. And I have here the positive 90x and the positive 6x, that means positive 96x. Some teacher, they like to put it into order. So we start with the highest degree and after that the lowest degree. So 96x minus 70 is going to be my final answer. The next one, again, distributive property, as you can see twice. So I'm going to say this is equal to negative 30b, negative 30 plus 5b plus 10. And now I can combine the like terms. So if I start with a negative 30b and 5b, that means negative 25b. And I see here the negative 30 and the positive 10. That means negative 20. And you see here, I simplified. I make it a little bit shorter than before. And I respect the order, b exponent 1, and here b exponent 0, because b exponent 0 equal to 1. So I put it into order. Thank you, and I hope that you understood the lesson. Thank you for your attention.